All right, here we go. Start of a new chapter. Here's your homework. Okay. You may recall this, you may not. In Algebra 1, you were introduced, maybe even in pre-algebra, you're introduced to a formula called the distance formula. And the distance formula will find the distance between any 2 points. This was presented to you as a fact in pre-algebra, Algebra 1, and in geometry, we finally prove it for you. All right, so do you remember the from last year, the distance formula? It's okay if you don't. All right, so in order to prove the distance formula, we're going to do a quick review. So coordinate plane, invented by a mathematician named Rene Descartes, and he placed 2 number lines at right angles to each other. The x number line tells your distance left and right, and the y-axis tells your distance up and down. Both number lines meet at their 0 points. They're at right angles, and we call the place where they intersect the origin. That O there doesn't mean 0. It does for both number lines, but it's called the origin. So that's actually an O, not a 0. The axes are the x-axis and the y-axis. And if you notice that geometry there would break things up into 4 parts, and we call those parts quadrants, and they make a big counterclockwise C. So you have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So think about this. If I had any 2 points, there's 4 points right there. If I had any 2 points, let's say I had points A and point B. Now, it's labeled right there as 4 units apart. Why? Because they're 4 squares apart, or 4 tick marks, or 4 lines apart from each other. So we would say they're 4 units apart. If you look at the coordinates of each one of those points, A and B, A is at 3, 4, B is at -1, 4. And if you think about what the coordinates really mean, the coordinates mean from the origin, how far are you away left and right, or up and down? Notice the how far they're away up and down never changes. The y coordinate is 4 for both points. So if we wanted to figure out how far it is from A to B or B to A, then we simply need to look at the x coordinates, because that's what's changing. And it's not a remarkable fact that if you subtract the 2, the x coordinate of point A and the x coordinate of point B, you get also to 4. Because remember, on a number line, the number of tick marks between any 2 points is the difference of their 2 coordinates. So 3 minus -1 would be 4. We run into a slight problem if we don't try to do that in opposite order. In other words, from B to A. If we follow that same pattern, subtract the x coordinates, we would get -1 minus 3, which would give us a -4, and that can't be true. So we put one caveat to this process. If you want to find the horizontal distance between any 2 points, take the absolute value of their difference. In other words, take the absolute value of the 2x value the 2x values subtracted from one another. And then it doesn't matter whether you do 3 minus -1 or -1 minus 3. When you take the absolute value, you get 4. Extend that idea to the y coordinates. The difference between C and D would be 3 units. It's labeled right there, or you could count the little squares or tick marks. And similarly, as for the x coordinates, since what doesn't change for 2 points that are the only difference is that they're one's placed above the other. Notice the x coordinates do not change for C and D, -3 and -3. But what is changing is the y values. 1 and -2 are the 2 y values. And so we follow that similar pattern. Just take the absolute value of the 2 y values. So C y value is 1, D y value is -2. So 1 minus -2 is 3. Take the absolute value of both, and it doesn't matter whether we go from C to D or D to C, we get 3. So put that in your head. The but here is that doesn't help us for when the line is diagonal. So great, go back one. We can calculate the horizontal distance or the vertical distance very easily just by subtracting for horizontal the x values and for vertical the y values, but that doesn't help us when the line is diagonal. Unless, since we're in high school geometry, and if we want to find the distance between those 2 points, we make a triangle. So notice if I go from the left dot right there straight down, and from the right dot right there, I go left and right, you form a right triangle. And the distance, that value, what I'm going to call right x right there, well, that would be Pythagorean theorem distance. So we can use that same trick to find the left and right, subtract the difference of the two x values, use the same trick to find the y value distance, subtract the two y values, and now we have two sides of a right triangle. To find the third, we can simply use the Pythagorean theorem. So that is what we're about to do. So let's see, 10 squared plus 6 squared would be what? 136, and the square root of 136, 4 times 34, 2 root 34 would be that distance x. Great. Sounds really complicated. The process takes a little bit of time. You need to graph, you need to draw a right triangle. But if we extend this a bit further, we can actually come up with a formula. And it's that formula that you saw before. So a quick talking proof here. Now I'm going to place a diagonal line somewhere on the XY plane. Yes, it looks like it's in quadrant 1 and quadrant 4, but I'm making no claims of where it actually is. So therefore, we would have to have two endpoints for the line, and the distance between those 2 points we're going to call D for distance. So the first point, the one on the left there, we'll call x1, y1, and the second point we'll call x2, y2. Now we're going to do the same trick that we just used. We're going to make a right triangle. Make a line that's parallel to the x-axis from that first point, make a line parallel to the y-axis from that second point, and we're going to form a right triangle. All right, so the only tricky part right here is to find, I'm going to draw it for you, is to find this point right here. So that point right there, well, let's see, where is that point? Well, that point right there would have the same x value as the second point, and it would have the same y value as the first point. So that point right there would be right there, the one that I just made in red, that one right there, would be x2, y1. Once again, it would have the same x value as the second point, and it would have the same y value as the first point. So now we can use that trick for horizontal line, vertical line, subtract the two values. So we have, let's see, the horizontal distance between the 2 points there would be, let's see, x2 minus x1, take the absolute value. And then we're going to throw the thing into the Pythagorean theorem. So let's see, a squared plus b squared equals c squared, except I call c d. So let's flip the equation around real quick. So we start off with letter D. I'm going to substitute for c squared d squared. So I really haven't changed anything. And then I'm going to do that distance between the horizontal points and the vertical points. So let's see, the distance between the two horizontal points would be the absolute value of x2 minus x1. That would be the a value, but since it's Pythagorean theorem, I have to square it, and then do the same thing for the y values. That would be y2 or the absolute value of y2 minus y1. And since that's the b value, and I'm throwing it into the Pythagorean theorem, I need to square it. Now, one little detail I'm going to well emerges from this is that if we subtract the two x values and then we square that, we're always going to get a positive value, right? When you square any number, positive or negative, you always wind up with a positive value. So I don't really need those absolute value symbols, so I'm going to get rid of them. Lastly, we're trying to find the value of d. So I don't want d squared, I want d. So I'm going to take the square root of both sides. Now, remember, when you take the square root of a variable, you get a plus or minus potential value. But since this is in geometry and the value of d is only positive, I don't need to put a plus or minus. I can just put the plus value. So that right there is that formula. Hopefully you remember, and that's the proof of why the distance formula looks like it does there in yellow. So let's put that in our book of truth here. This is theorem 13.1. It's the distance formula, and it says the distance between any 2 points is given by the formula, the one there in yellow. So let's see, d is equal to the square root of the square of the difference of the two x values plus the square of the difference of the two y values. Okay, so remember, it looks like a very complicated formula, and it's somewhat complicated, but it really is just the Pythagorean theorem in disguise. So let's do a couple right here. I'm going to give you an easy one to start off. We'll do a bit more challenging one in a second. So I have a segment there. It's not labeled what the name of it is, but I do have the two endpoints, -4, 2, and 2, -1. Now notice I've had this graphed, and I made a right triangle there, and I've already listed the values there. That's not how the problem normally is. Normally you'll just have the two endpoints. But I wanted just to show you that this is in fact how these values are calculated. All right, if I were presented a problem like this, I wouldn't use the distance formula. I would just go write Pythagorean theorem. But pretend like you only have the two endpoints, -4, 2, and 2, -1. Therefore, I'm going to throw those two values into the distance formula. That means I need to label first. And it doesn't matter which is 0.1 and 0.2. You can pick either one as your 0.1 or 0.2. So I'm picking -4, 2 as 0.1 and 2, -1 as point number 2. So I need to label the values, and it's important to label. Typically, if you make a mistake here, it's because you have plugged the wrong values in. So it's worth doing this step. So the first point would have x value and y value of 0.1, and the second point will be x2, y2. Common mistake is to label them x1, x2, but it's not. It's x1, y1. Now all we do is just plug and chug. So plug those values. The formula says the square root, big long square root symbol, open parentheses, x2 is 2 minus x1 is -4, and then throw the other values in. Typically, you will have a lot of negatives to deal with. Two negatives make a positive. 2 plus 4 is 6. -1 minus 2 is -3. Notice once again, when we square, we get rid of that negative, so we get 36 plus 9, which is 45. And inside of 45 is 9 times 5. And the square root of 9 is 3. So we get 3 root 5 units. That is the exact value. If the question tonight for homework asks for the approximate value, what they're asking you to do is throw that into your calculator. In other words, do 3 times the square root of 5, and that would be about 6.5. Notice I've left off the word units. There should be the word units there. All right, if you need to see that again, go ahead and rewind, play that again. As I stated before, typically you don't get this picture, right? You get this. You're just handed 2 points, and you're asked what's the difference between the two, or distance between the 2 points. So as always, label is your first step. You need to label one as 0.1, label as 0.2. Either label them like that or the x1, y1, x2, y2. It's your choice. I'm giving you two options right here. Some people like this technique right here. And just throw the values in. So the distance formula says d is equal to the square root of, open parentheses, x value of 0.2. That would be 2 minus 3 squared plus 4 minus 8 squared. And then it's just a little bit of simplification. 2 minus 3 is -1. 4 minus 8 is -4. Square both of those, we get 1 and 16. That would give me the square root of 17. And that's the exact value. Square root of 17. Approximate value, toss that into your calculator, and you get about 4.1. All right, hopefully this is a review. If it's not, I'm talking a little fast here. Make sure you rewind, watch it again. We'll do one more. I've already labeled them for him, but remember that's always first step. So this one has lots and lots and lots of negatives in here. So just be careful with the negatives. So let's see, the x value of 0.2 is -4 minus the x value of 0.1 is -1. So I get -4 minus -1. Notice lots and lots and lots of negatives there. And then the second for the y value is -6 minus 3. Two negatives make a positive. So that would be -4 plus 1, which would be -3. And -6 minus 3 is -9. Another common error is that kids get really lazy, and they're like, I don't want to draw the square root symbol on each one of these steps. And they're like, I'll just remember to put it back in as the last step, and you will forget to. So make sure you leave the square root symbol in there. All right, so -3 squared is 9, -9 squared is 81. That gives me 90. 9 times 10 is 90, and the square root of 9 is 3. So 3 root 10 exact. approximate would be about 9.5. All right, anything else? I'm going to show you, well, there is something. The rest of the class, this is brand new. So the distance formula was a review, but this is brand new. I'll try to slow down a little bit here. Math is cool at some points. Imagine this. Imagine you have the center of the circle and you place it on the coordinate plane. I don't know where it is, so I'm just going to call the center of the circle AB. Circles all have radius, so I'm going to call the radius R. And circles are made up of the collection of points that are all the same distance r away from a center. So I'm just claiming that point P is some point on the circle, and I'm telling you the values are x, y. I'm not claiming anything's positive or negative other than the radius is clearly has to be positive. That's the only thing I will claim. Watch this magic, right? Well, radius never changes, so it's a distance. And since I now have 2 points, I have point C and point P, I can actually calculate the distance of R using the distance formula. We'll just call dr, right? So I have 2 points, the center and the point on the circle itself. That's A, B, and X, Y, right? Just label those suckers right up and throw those values into the distance formula, except called dr. So let's see, that would be X minus A squared plus y minus b squared. And since nobody likes square roots in their formulas, how about we square both sides this time? And that would give me r squared is equal to that. And believe it or not, what we just did was a proof right there. And what's written in yellow is not just the distance formula, it's the formula for a circle. Circles are all defined as points on a plane a given distance away from a center, and that's what that equation right there states. It says if you have r squared, then it's equal to the sum of the squares of the difference of the 2 points between the center and the point on the circle. So that's kind of crazy. Remember the formula says r squared, not r, so r is the radius and AB is the center. And then lastly, what I want you to notice is the formula says x minus A and y minus B. So the center of the circle is, as long as those two inner parts of the parentheses are negative or minus signs, then you strip off the A and the B. That was a proof too. We better write this down. This is 13.2. So it says the equation of a circle of centered AB and the radius of R is given by the formula R squared is equal to the square of the difference of X and A added to the square of the difference of Y and B. Okay, given that information, we're going to do 3 games about circles. These are all 3 easy games. So the first game is I'm going to hand you the equation of a circle. I will tell you that, and you will find the center and the radius. Okay, not a very challenging thing. You just need to remember 2 things. The first thing you need to remember is the center is at points A and B, and A and B should be negative. And look at our formula that says -3 and -4. So the center is not at -3, -4, because the equation of the circle is negative on the inside of the parentheses. So therefore, the center for this particular circle is at 3, 4. Right? I'm not sure why I highlighted the minus sign right there. I didn't need to. Lastly, you'll be asked, what's the radius? Well, the radius is not r squared. The radius is r. So I just simply need to look at the equation of the circle and take the square root of whatever's on the left side of the equal sign. Well, that's 25, and the square root of 25 is 5. So the radius is 5. So there's our first game. Identify the center and identify the radius of a circle from its formula. All right, let's see another one. So here we go. Let's see, our formula wants the inside both to be negative. Hey, only one of these is negative. So the B is negative, so therefore the B is 6, but the A value is positive in what we were given there in blue, so that means the real value would be negative, right? If you throw a -2 in there, then that would in for A, -2 would turn into a +2. So it's the opposite of whatever's inside the formula. If there's a +2, the answer is negative. If there's a -6, the answer is a +6. Hopefully that made sense. Play that again if you need to. Lastly, the radius is always the square root of the value that we're given. Hey, we're given 125. Let's take the square root of both sides. 25 goes into 125, what, 5 times? So let's see, that would be 5 root 5. And there's your radius. So that's your first game. I only showed you 2 examples. Typically, students get it after those 2 examples. If you need to play those 2 examples again, please do that. And just remember, the key here is that it's the opposite of A and B inside of your formula will be the center. The opposite of 2 is -2. The opposite of -6 is 6. All right, I said 3 games. We're on to game number 2. So it says, oh, it's the same game. It says find the center and find the radius, but there's something else. Then it says sketch a graph of it. Okay, so let's see this again. Remember, we want the opposite of the number for both to be the center. So let's see, A and B. A is going to be the opposite of -1 is 1. The opposite of 2 is -2. So the center is at 1, -2. The radius is always going to be the square root. So the radius of 9 is 3. So now I have the center and the radius. Well, how do you graph that? Well, graph the center first. That's at 1, -2. Put a big dot right there. And now the radius is 3. So that means anywhere from that black dot, 3 units away is where the circle lives. Probably the easiest way to do it is put 4 dots, 3 above, 3 to the right, 3 below it, 3 to the left. This time when you play connect the dots, don't make straight lines because that would make it a square. You need to make curved lines, or you could use your compass as well too. Just measure 3 units away from that black dot and draw your circle. Once again, most kids get this immediately. I only have one example here. If you need to see another example, play this one again, or just ask me to give you another example for help. So the last of the 3 games is this. They're going to ask you to write the equation of a circle given the information. Well, they have to give you 2 things. They have to give you the center and they have to give you the radius. All right, so if they give you the center and the radius, you're just throwing those values in. For R, I'm going to throw 4, so that'd be 4 squared. And for A and B, I'm throwing -3 and -6. Well, a negative A would make it +3, and a negative B would make it a +6 as well too. And I square 4 and I get 16. So there is your equation of the circle. One more time. Sometimes they'll throw in some strange values right here. So let's see. The formula says the opposite of A, the opposite of B. So let's see. The opposite of 10 would be -10, and the opposite of -6 would be +6. So I'm going to get an x -10 and a y +6. Lastly, what I need to do is I need to square the radius. So let's see. If I square the square root of 7, that's just plain old 7. And there you go. There's the equation of a circle. I lied. We're doing it one more time. So yeah, sometimes you get hung up on the fractions when the radius is a fraction. Still the same process. So the formula says I need the opposite of A, I need the opposite of B. So the opposite of A in this case would be -11. That would be a +11. And the opposite of 3 would be -3. So I'm going to get an x plus 11 squared plus y -3 squared. And you remember how to square fractions? So all we need to do to square a fraction is square the numerator, square the denominator. Square 2 is 4, square 3 is 9, so we get 4/9. Don't panic just because there's a fraction. Okay, I typically show all kids this. This isn't part of the lesson, but most kids say, hey, it's graphing calculator. Can I use my graphing calculator to graph circles? Well, circles are not functions. Remember, they fail the vertical line test. So you can, but there's got to be a little trick involved. So how do we graph a circle with its center at the origin, in other words, 0, 0, and has a radius of 4? Now, we'll just use a quick trick to do that. And if you don't need to do this if you're not interested. All right, so there's my formula. It says it's at the origin, so that means A and B are both zeros. And x minus 0 is x squared is x squared, and y minus 0 is y, so we get y squared. That's equal to r squared. And remember, on our calculator, we have to have it in the form of y equals, so I need to solve that equation right there. R squared is equal to x squared plus y squared for y. So just a little bit of algebra. Let's see. I'm going to move the x squared to the other side. So I would get y squared is equal to r squared minus x squared. And then I got to take the square root of both sides. Now, if you take the square root of that variable, you need a plus or minus. We're not doing a side of a triangle, so this one would be plus or minus. There is no plus or minus key on your calculator. So what we do to trick our calculator is we simply graph two equations. The first one will be the positive version, and the second one will be the negative version, and that's how we get a plus or minus. So when you graph this on your calculator, if you choose to do this, you're going to see it's going to draw the upper half of the circle, the semicircle first, and then it'll draw the second one. All right, so what was our radius? Our radius is 4, so that r squared there, 4 squared would be 16. So here's what you would type in if you want to do this. Here's what you would, in yellow there, what you would type into your calculator. Just be careful on that second equation there. It says minus the square root of 16 minus x squared. Remember, on a TI, you need to put a negative key, not the minus key. So make sure you do that. That's usually what, if you get an error, it's because you typed in minus instead of negative. When you draw this, you're going to get a squash circle, and everybody complains. On the TI calculator, since the screen itself is rectangular, it squishes the circle down. If you hit zoom square, that's that button there at the very middle, very top middle button, that's the zoom button. If you change that to negative square root, I'm sorry, if you change the zoom to the square feature, you get a perfect circle. So most kids want to do that just because they enjoy doing that. All right. And this is just the last slide right here, just to mention the fact that circles do not pass the vertical line test. So this is why that we can't type in that equation right there in blue into our calculator, because it's actually not a function. And for it to be y equal, we need to have functions. All right. I'll skip that, and that's just an explanation of what we got. So one quick note for questions 1 through 12, just use the distance formula. It's going to say graph, but you just use the distance formula to find the distance between any 2 points. That'll be good enough. And I think that does it for today. If you run into any problems, send me an email. I'll be happy to help you out. And I will catch you next class.